But if you drop below it, your data is worthless. Right? You start all over again. Or I don't know what exactly we're doing. Okay, or something like that. Just try not to do that. Okay, so now the first thing is this. I'm ready to do this thing now. So I'm going to go ahead and take my initial volume measurement. So as Dave mentioned, and I have a picture over here, it's going to read the bottom of the meniscus, which looks like a concave, right, or a U below. And this thing is reading about, let me sure it's eye level, so 8.7, so 8.7. 0.70 milliliters right now. That's where it's at right now. That's your volume. Now, the last digit over here, okay, I was able to estimate it because the actual bottom of the meniscus, it happens to be touching one of the tick marks. So therefore, that's considered 0, and that 0 counts. This last digit in a measure number, an A-type measure number, is called what? Huh? The uncertainty marks, right? So it's also called what? It contains uncertainty in them. It's also referred to as what kind of a digit? The estimated one. Exactly. That's what they meant. Remember, these things are graduated to about 1/10 of a milliliter. Okay, so they can know what it is. But you can actually measure one more digit, which contains an uncertainty. Okay, so it's the last digit. Okay, that's called the estimated. Okay, so that'll be you guys all the time. So make sure that when you guys take a measurement, you have at least 2 digits after decimal point. Okay, most of our students don't pay attention. Don't. Right? And then when I see their data, as you're walking around, they only give me 1 after decimal point. You completely do not listen. Okay, so make sure you guys have this with data. Now the first 2 digits here, and of course if you're going to navigate the picture in here, those are known as your known digits. Okay, those are exact. You know exactly what they are because the instrument's telling me that is what it is. Okay? So, but regardless, even when you have the known digits and estimated digits, you know, they're all significant. Okay? Alright, so that's the first thing there. Now, what we're going to do is, we're going to start the actual titration. So, I'm going to try to take this one away. Now, I'm going to put right below is the actual preliminary flask with our acidic, with the vinegar in it. Okay? Now, at this point, all we're going to do is just start stirring this thing up. Remember, at the end point is where you're trying to achieve, also not referred to as the equivalence point. Okay? You kind of think of it kind of like being equilibrium, where you pretty much have equals amount of the acid and base, but you're trying to reach the end point, where you have mostly all the acids reacted away, and you have some, and you still have basic forward. If you go too dark pink, then Missy's all basic. So that's the idea. That's when you know when to stop. You want to pale pink color. And you have to wait 10 seconds. Okay? So it takes seconds to stay there after you mixed it. If it stays that color, congratulations, it's done. That's it. Okay? And then you take your final read. Alright, so let's start doing this. Okay? So for this thing, what I'm going to start doing is just open the spout here and out here and start doing this between the side. Now, for some of you guys are fun, you guys start seeing that as a stream, which has some dark side hits the acid solution, that it's already turning pink. Now, the stream that it hits is going to be pink because that's all sodium hydroxide, so it's very concentrated. So, of course, it's going to make the phenolphthalein there pink. Okay? That's how you know at least you have added the drops. If you don't see any pink, you should stop and add the drops. Okay? Alright. So now in the beginning, we can go fast and I can just stir it up as to do this. Okay? As you start getting closer to that end point, you hear it. I'm going to what happens is the solution will start to remain this pale pink color. But the reason why I stir it is because that way to see whether or not I have any excess or still remaining acid left over. Right? Because as soon as you stir it up, as soon as you shake it, it's going to go away. This technique also requires some patience. You don't really want to rush this thing. And don't be discouraged that if you're almost there, and also you do one little shake, boom, it's gone. Okay? Don't worry about it. Okay? That means you're almost there at the end point. So keep shaking it. Okay? So now, you see here, that it's starting to take longer pink, right? So then you can start to get rid of some of the acid. As Dave's mentioning, it's a weak acid, it's reversible. That means you get the acidic acid back again. but the sodium hydroxide consumes all those protons, and at the end, you should have hardly any of the acid left over. And afterwards, as you get good at this stuff here, because maybe you need maybe a few drops, or maybe half a drop, or a quarter of a drop, okay? Because you're almost there. If you add like maybe one whole drop, it turns dark pink. Okay? A quarter of a drop, or it's basically having the drop come out and letting it touch the tip at the glass and then it run down. At that point, as they mentioned, is when you guys should also take your squirt bottle, like the distilled water in there, and simply let it just squirt it on the ground, the sides here. So that way, any of the actual base that happens to splash hits the glass, it has to count, so no index to react. Also, any of the acid, as it was hitting me splashed above, same thing, you want it to react as well. So from time to time, you want to do that as well, okay? But for purposes, huh? Oh, yeah, I think so. And one thing you're gonna notice, we kind of give the answers away all the time. It's just we want to see if the students are actually writing down anything, and most of them don't. So, oh well, you know. Anyway, so let's keep going with this. So after we just kind of back off and you add a couple drops, mix it up. Switch it up. So like I said, if you get really, really good at it, it's almost there. See, now it's taking longer, right? So I know I must be there. So I start to, now, see right now here, there's a little drop, right? Hanging right down below. Now for that, I want to make sure I collect it, because see, that's already been taken account with the volume. So what I'm going to do is I'm going to simply touch the side of the glass, and then I'm going to do is take my squirt bottle and just rinse it. So I want to make sure it falls in there. Because like I said, that's part of the volume at the end of the count, and that thing has to react with this. Okay? Because if you add, if I let it go more drops, it can be really throw you over into the dark pink region. Okay? So. There we go. Alright, now I'm gonna steer. I'm gonna back off. Now there is the one there also. I'm gonna see if I use it or not, but I'm gonna wait 10 seconds. Okay? And since it's not changing, it pretty much makes the equivalence point. And I'll just grab that and I'll squeeze around here, collect it, and that's it. Done. See? So that's what you want to get. Now, compare this one to this one. However, okay. So it's not that bad. Okay, this one here, the one that they started in the beginning, it was kind of like this, but something's been happening to this thing here. Okay, does it look the same color as this one? Does it look the same color as that one? All right, it's actually done what now? Paler. It's more pale. All right, this is darker than this one here, but it's been sitting down here. Can any explain why? What do you guys think? How come it's actually lighting it up, being paler?
It's reversing.
It's reversing. What is reversing?
I don't know.
The vinegar is reestablishing its acid, like.
So she said that the vinegar is reestablishing to form an acid. I think you got part of it right. It has nothing to do with the acid, but it's not the vinegar that's doing it. Remember, all the vinegar at this point should react. So it's not where it's coming from, but it is an acid. Remember, it has to go back and forth, right? When it was colorless, right, in this thing right here, it's basically in what type of solution? What type? Is it basic?
Acidic.
Acidic. That's why it's colorless.
Oh,
when it becomes basic, it turns what color? Pink. So how do you get it to go backwards then? You gotta add a what? If I added an acid to this thing, it would do what? Clear up. Right, it would clear up. So what do you think the acid, what do you think, what type of acid is doing this then? It can't be the vinegar.
So it'd be the droplets?
It's been sitting out here, we've been talking, so have you guys. I've been talking around it. And so you guys are breathing.
Who's been respiring? Who's been respiring?
Oxygen?
Who's been breathing?
Been breathing.
What comes out when you breathe?
Carbon dioxide.
What happens when you mix carbon dioxide and water?
Carbon? No. What do you think? You take carbon dioxide and water. Here, go ahead and talk and switch.
You have oxygen together?
Say something. Alright, pass it around, see. Pass it around. See what happens.